Hello students, welcome back to my YouTube channel Mathematical Lens by Namita. In this video, we are going to continue with chapter number 3, number play of the new NCERT textbook Ganitha Prakash. Okay, and in this video, we are going to discuss the figure it out exercise which is given on page number 72 and 73, which is the last exercise of this chapter. Okay, so let us see first question. There is only one supercell here. You can see the one which is colored is a supercell. Why it is a supercell? Because all the numbers, neighbor numbers, they are less than this number. Okay, 62,000 is greatest and all the neighboring numbers are smaller than that, 62,871. Now what they have asked, if you exchange two digits of one of the numbers, so out of all these 9 numbers, if you exchange 2 digits of any one number, there will be 4 supercells. You want 4 supercells, right? So you have to exchange the digits of any one number, 2 digits of any one number. Okay, that should be clear. First, you should understand the question. Now, if I try to exchange any of this, 1, 2, 3, this or this, maximum 3 supercells I can get. Maximum 3. But if I change the number which is in the center, which is already a supercell, and if I make it smallest out of all these 4, so you will get 4 supercells, right? So let us see, the number here is 62,871. Now, if we exchange the first and the last digit, because we need it to be the smallest. So 1 can be the first digit, 1 and 6 if we exchange. So this number becomes 12,876. So if this is 12,876 and you see the neighboring numbers, like if I see this one, it will become a supercell because all the neighboring numbers will be smaller. If I see this second one, the neighboring numbers, see these two are already small. We want only the third one to be small, then it will become a supercell. Here also if we see this is greater than both the neighboring numbers, it is only smaller than this. So now we have made this smaller, so this also becomes a supercell. If we see 45,306, it is greater than both the neighboring numbers, but it is smaller than this. So now we have made this 12,876. So this also became a supercell. So we got 4 supercells. Okay, so we have just exchanged the digits of the middle number. 1 and 6 is exchanged. Okay, is it clear? Okay. Now, there is a question. How many rounds does your year of birth take to reach the Capricus constant? Okay, so suppose I take the year 1976. Okay. So do you remember the Capricus constant? How do we get? We form the largest number out of this, smallest number, and then find out the difference. And till we get the Capricus constant. What was the Capricus constant? 6174. What is important is first you understand the question. Okay, then we go ahead with the steps. Okay, so now let us try to get the answer. So answer number 3, we will try to solve it over here. The year which we have chosen is 1976. You can choose your own year and we want the Capricus constant. So let us form the largest number. So largest is 9761 and the smallest is 1679. If we try to find out the difference is 8082. Okay. Now again we form the largest with this number which we have got. So it will be 8820. Smallest will be 0288. Clear? So the difference would be 8532. Okay, now this is already a largest number, but we still write the next step over here. Always write it this way so that you can count the number of steps also. 2, 3, 5, 8. Now if we subtract this, the difference is 6174, which is Capricorn's constant. In how many steps we got this answer? In 3 steps. So you can choose your, these are the 3 steps. This is step number 1, step number 2, and step number 3. Okay, so you can choose your own here and find out Capricorn's constant. In how many steps do you reach that constant? Okay, so the answer may vary from person to person. You can write 3 rounds. Now question number 3, we are the group of 5-digit numbers between 35,000 and 75,000 such that all our digits are odd, right? Just note this point, all our digits are odd. Who is the largest in our group and who is the smallest in our group? And who among us is closest to 3 answers we need to give. Okay, so let us try first of all which are the odd numbers between 35,000. All digits should be odd, that you need to remember. So we write answer number 3, that is the range is 35,000 to 75,000. So now if we want all the digits to be odd, the numbers like it will be, if we take 3 and 5 both are odd numbers. So 3, 35,000. We can't take 0, 0 because 0, 0 is even. So it will be 1, 1, 1. Okay, that would be the first number. Okay, after 35, because 35 we need to keep as it is. You can't take 0. After 0, 1 comes. So 1, 1, 1. This is the smallest number you need. Okay, now to get the largest number, we need to go below this 75,000. Now below 75,000, here both are odd, 7 and 5 are odd, but 0, 0 is not odd, it comes in even. So then we can't go, so any range of 75 is not possible. Like if we go 7 below this, then it will be 74,499 like that. So 4 is even, so we can't consider that. So we need to go to 73. Okay, 73,000. Now we want to form the largest number. So we start with the largest odd digit. So largest odd digit is 9. So if you want the largest number, we keep all 3 of them as 9. So largest number is 73,999. Okay. And the third question is, who is closest among 50,000? So out of all the numbers between this, which have odd digits, which is closest to 50,000? So now there are 2 possibilities in this. Closest is, we take the nearby number. If we take it as 50,000, 51,111, this is one number. And if we go back, it will be, if we can't take the series of 4 because 4 is even number. So we will have to go to 3, 9, 9, 9. Now if we see out of this, which is closer is, let me just write this again. 51,111, right? If we take 53, then it becomes a little far. So we need to keep close to this. So out of this, which is closest is 51,111. Question number 4. Estimate the number of holidays you get in a year, including weekends, festival, and vacation. Then try to get an exact number and see how close your estimate is. So if you remember, in one of the question we estimated the working days, okay, in the previous one of the exercise. So we estimated it as 200. So out of 365, we subtract 200, so maybe holidays are 165. This is our estimate. Now, if you calculate the exact number, then it depends from school to school. So you may get, like, suppose exact number is around 135. So you are a little far away from the estimate. If you get a number around 160 or 170, then you are very close to the estimate. So this estimate questions and answers may vary from school to school, from person to person. Okay. So nothing is wrong in that. Question number 5. Estimate the number of liters in a mug, a bucket, and an overhead tank. So again, this is you have to estimate. So number of liters in a mug may be 1 liter, depends. It may be 0.5 liter if it is a small mug, and it may be 1 liter also. So both possibilities are there. 0.5 liters or 1 liter. Then if we talk about the bucket, first I'm writing about mug, 0.5 or 1 liter. Bucket also may vary. It may be 15 liter, 20 liter. So we write it here as 20 liters. Overhead tank, these may vary from, again I'm telling you, these are estimate sums. So around 2000 liters. Okay. So these answers may vary. So we have just written the estimated one. Question number 6 is, write one 5-digit number and two 3-digit numbers such that their sum is 18,670. So we need one 5-digit number and two 3-digit numbers. So what we can do, we want one 5-digit number, so that's easy. You can take it as 18,000. Okay. Now this 670, it's a 3-digit number. So that you can split into two 3-digit number and you can get many combinations. Like suppose I take 300 plus 370. You may take 500 plus 170. 400 plus 270. There are many possibilities. So to make it simple, first separate the 5-digit number, that is 18,000, and then take any combination of the 3-digit number. Okay. So that will be your answer. You can write your own answer. Question number 7. Choose a number between 210 to 390. Create a number pattern similar to those shown in 3.9 that will sum up to this number. So the range is 210 to 390. So you can choose any number. I'll just show you which pattern are they talking about. So this one. So you can choose any of this pattern and choose any number between 210 to 390. So let us try to do that. So let us choose a number that is 300. Okay. So we choose a number 300. So now 300, there are many possibilities. You can take it as 30 into 10. You can take it as 40 into 6 maybe, plus 20 into 4, right? You can take any of these combination and make a pattern over here. So suppose I choose this 40 into 6 and 20 into 4. So we arrange it in this way, maybe 20, 20 here. Then we keep 40, 40, 40 and 40. Then again we take 20, 20. So we have already got 4 20s and 4 40s. We need 6 40s actually. So what we'll do, we will keep only 140 over here. So that you want a pattern also, not only the numbers, but there's a pattern. So 3 we have included over here. So 3 more you can write over here. and you can make a box around it or a circle around it and create a pattern. So there are many possible answers in this. Okay, you can make a pattern of your own choice. Shape you can choose, numbers you can choose, between 210 to 390 you can choose any number. I have taken 300. It is not necessary that you take the same number. Clear? Question number 7. Now let us go to the next question. That is question number 8. Now recall the sequence of powers of 2 from chapter 1. You remember chapter 1 we did power of 2, power of 3, we did pattern in mathematics. That chapter they are talking about. So why is the Collatz conjecture correct for all the numbers in this sequence? Okay. So first let us go to this Collatz conjecture. If you remember, I'll just recap that. If you take any number, if you start with any number, if it is even, half it. If it is odd, then triple it plus 1. Okay. But here they are talking about power of 2. So first let us write the sequence of power of 2. In power of 2, which numbers were there? 2, 4, 6. No, sorry, not 6. 2, 4, 8. Then 16, we need to keep doubling them. 16, 32, 64. Right? So what they say that you start with any of the number. So we take some bigger numbers. Suppose we take 32. Okay. 32. If we apply Collatz conjecture here, 32 is even, half is 16, half of 16 is 8, half of 8 is 4, half of 4 is 2, half of 2 is 1. Right? So what is happening here? You are all are multiples of 2. So they are all even numbers. If I take 64, then also half of 64 is 32. Then after 32, I'll get the same sequence, 16, then 8, then 4, then 2, and then 1. So why is this happening? Why Collatz conjecture is correct for all the starting numbers in this sequence? Because all are multiples of 2. So you'll write all are, you can say multiples of 2, or you can even say all are divisible by 2. You can write in any form, all are divisible by 2. That is, they are all even numbers. So all are even numbers, so you can just keep on dividing by 2 and you will reach 1 eventually. So all are divisible by 2, that is all are even numbers, which eventually leads to 1. This, you can write a sentence in the answer. Clear? This is answer number 8. Now let us see the next question. Question number 9. Check if the Collatz conjecture holds for the starting number 100. Okay. So let us try to solve that. We start with the number 10. This is, 100. Answer number 9. 100 is even. So half it, you get 50. 50 is also even. Half it, you get 25. 25 is odd. So triple it. So multiply by 3 plus 1. So 25 3s are 75. Plus 1 you get 76. 76 is even. So half it you get 38. 38 is even. Half it you get 19. Now 19 is odd. So multiplied by 3 plus 1. So 19 3s are 57. Plus 1 is 58. Which is again even. So half it, you get 29. 29 is odd. So triple it plus 1. So 29 threes are 87. 87 plus 1 is 82. 82 is even. Half it, so you get 44. 44 is also even. Half it, you get 22. 22 is also even. You half it, you get 11. Okay. Now 11 is odd. So multiplied by 3 plus 1, 11 threes are 33 plus 1 is 34. 34 is even, half it, so you get 17. 17 is odd. So 17 threes are 51 plus 1 is 52. 52, half of 52 is 26. Half of 26 is 13. 13 is again odd number. So you multiply it by 3 plus 1. 13 threes are 39 plus 1 is 40. Half of 40 is 20. Half of 20 is 10. Half of 10 is 5. Okay. Now 5 is odd, so triple it. So 5 threes are 15 plus 1 gives you 16. Half of 16 is 8. Half of 8 is 4. Half of 4 is 2. And half of 2 is 1. My God, so many steps, isn't it? But that's fun. Actually, you get to do a lot of mental maths in this. So, but eventually we reached the number 1, right? So, it holds true for number 100. Okay, so this is answer number 9. So, now let us see the last question. Check, starting question number 10, starting with 0, players alternately adding numbers between 1 and 3. The first person to reach 22 wins. Okay. So, what is the winning strategy, right? So, if you remember, the winning strategy of number 21. Okay. So, in 21, what were we doing? What was the strategy? That the person should reach 18. Okay. Once the opposite person says 18, you can add 3 and get 21 easily. Okay. So the last number they were saying 18. It was 3 less than that. Right. So here it is 22. So 22 minus 3 is 19. So what should be your strategy? That the opposite person says 19. As soon as the person says 19, you add 3 and get 22, so you win. So your target number is 19. So say such numbers, add such numbers that the opposite person says 19. Then you can easily win the game. So that's the strategy. Okay. So with this, we complete the exercise, the figure it out exercise of chapter number 3. This is the last exercise. We will meet in the new video, in the new playlist of next chapter. Thank you. If you have not subscribed, kindly subscribe and share with others.